Hey class. This week in the discussions we're talking about different ways to solve a system of linear equations, and specifically we're looking at substitution, elimination, and the matrix methods. But before we get into that, I just kind of wanted to take a step back just to make sure we're all on the same page. So a linear equation or a linear function is one that has one x variable and one y variable. And I should be more general and say one independent variable and one dependent variable. And it really could be any two variables you want it to. However, for convention, we use the dependent to be y and the independent to be x. Okay? So you can perhaps find a function like this. Okay? This is called the slope-intercept form. And what you notice is that we have a y and we have an x. Okay? You can also find linear functions like this. Ax plus by plus c equals 0. And this is the standard form of a linear equation. Now, if we had more than one of these formulas, like this, for instance, then we have what's called a system of linear equations. In fact, the word system means that you have more than one equation. It could be 2, 3, 4, 6, whatever. Okay? So in our case, what we're trying to do is find a solution to this system of linear equations. Okay? So let's begin. So here's the key, okay? I'll give you the end of the story at the beginning. If we have the same number of equations as unknowns, then we have a unique solution. That means we can solve x equals something, y is equal to something, z is equal to something. However, if we have more equations than unknowns, then I don't have enough information to solve the problem. So it's called an underdetermined set. Okay? However, if I have multiple equations for multiple variables and fewer unknowns, I have an overdetermined set. Okay? And one of those cases you'll recognize if, for example, I have two equations and three unknowns, then that third unknown can be anything it wants to be, and I can have an infinite number of solutions. On the other hand, if I've overspecified a particular set of functions, then I might not have a solution because I'm being too specific and I don't have enough information to solve it uniquely. Okay? So one of the first ones we're going to talk about is this idea of substitution. Okay? For substitution, the general point is that you solve for one equation. You solve for one variable using one equation, and then you take that equation, the value of that variable, and plug it into the other equation. Okay? And it's pretty simple to show. So I've derived, let's say, here's an example. 4x minus 3y is negative 7. And 2x, let's say, plus 7y is equal to 39. Okay? So for substitution, we're solving for a particular variable. And it doesn't really matter which one you solve for. However, in this case, I think I want to solve for the x using the second equation. Okay? So if you took this second equation and simplified it in terms of x, you'd have 2x is 39 minus 7y. And divided by 2, you have x is equal to 39 over 2 minus 7 halves y. Okay? So this is the value of x. So we take that value of x and we plug it into the first equation and try to solve for it. Okay? So let's do that. So if you look at the first equation, 4 times, now x of course is 39 over 2 minus 7 halves y equals negative 7. And, sorry, I've missed one. That's all x. So we have to subtract off the 3y and then equals negative 7. Okay? So let's simplify this. 4 divided by 2 is 2, so I have 78 over 2. Minus 4 divided by 2 is 2, I have 14 over 2. Y. Minus, now this is 3y. I know 3y is 6 over 2, so I'll say 6 over 2y is negative 7. Okay? I see a lot of 2's here, so let's just multiply everything by 2 and get rid of it. Okay? So if I do that, I'd have 78 minus 14y minus 6y is negative 14. Okay? Sorry about that. Okay. Now remember that, and then we're going to take this and solve it for y. So if I took 78 on the other side, I'd have a negative 92, looks like. And on this side, I have a negative 20y. Okay? So what do we do with this? Well, first thing we want to do is make sure all of your math worked. And it looks like looks like all of my math works. Okay? Let's simplify it. So I took another look at the algebra here. And if you noticed, when you look here, looks like we might have went astray a little bit. So I'm going to actually erase this part because we can't actually get to where we need to get from there. Okay? But if you look at it, once you cancel off the 4 from the 2, that's just this line, 78. And when you subtract the 4 from the 2, that's this line, 14. And then this is 14 minus 3y, okay? And this remains negative 7. Okay? So now from this point, we can see 78 minus a 17y is equal to a negative 7. So if we bring the 7 on this side and take the 17 on that side, we have 85 is equal to 17y, which shows you that y is equal to 5. Now when we have 5, we can plug it into our original equation and solve for it. So 4x minus 3 times 5 equals negative 7. So this is negative 15 equals negative 7. 4x is here. 4x is equal to 8. So x is equal to 2. So using the substitution method, you can see that your answer, or your solution, is 2, 5. And if you plugged it back in, you can check to make sure that your answer is correct by getting a statement that's true. So if you plugged in 2 here and 5 here, 4 times 2 is 8 minus 15. 8 minus 15 is negative 7. So that works. 2 times 2 is 4. 4 plus 7 times 5 is 35. 4 plus 35 is 39. That works. So you can see using the substitution method, we just solve for one variable, plug it back in, and solve for the other. Okay? Let's keep this same equation, except this time solve using the elimination method. Okay? So I'll multiply it by negative 2. Yeah? So when you multiply it by negative 2, the first equation doesn't change, still this. But the second equation actually becomes negative 4x minus 14y equals a negative 78. Okay? From here, you just add them. Okay? So you should see that these cancel out. You'd end up with negative 17y is negative 85, and you end up with y is equal to 5. Now, because you've made this into one equation, you have to take this value and plug it back into one of these equations to get your other number. So we can see again, if you took 4x minus 3y equals negative 7, and we see this is 3 times 5, which gives us 15. Okay. And this is 4x. Then when you simplify it, you'd find out that x is equal to 2. Again, we get 2, 5 for the answer. So elimination is okay. However, once you get to a value, you still have to kind of use substitution to find out the value of the other variable. So now, since we use the two that most people find easiest, let's try to use the matrix method and kind of see where we're going from here. So the matrix method, 4x minus 3y is equal to negative 7, and 2x plus 7y is equal to 39. One of the things that most people don't understand about the matrix is that the matrix is developed just by the coefficients of the variables. So in the first column is your first variable x, and the second column is your variable y. And then we have on the other side of this kind of partition here, your values on the right-hand side. Okay? So you can see if you read this, you'd have 4x minus 3y equals negative 7, and 2x plus 7y equals 39. With the matrix method, the idea is to get ones on the diagonal and zeros everywhere else. Okay? So for argument's sake, I will take this first value, 4, okay, and say, okay, what can I multiply 4 by to get a 1 on that corner? Of course, the answer is 1/4. So if I were to multiply the first equation by itself, I'd get 1, negative 3/4, negative 7/4. Okay, so then we had 7/4. Right? The first one doesn't change, 2, 7, 39. So one of the things you have to do, once you have the 1 on the corner, the next thing you want to do is try to find a 0 off corner. So what you're trying to figure out is what can I multiply my equation by that when added to the next equation, I can get a 0 underneath that 1. So if I multiply 1 by a negative 2, right, that gives us negative 2 in that spot. And then if I add to the 2, I'd get a 0. Okay? So let's do that. Realize that the first values don't change at all. Okay? Now for the second one, we take 1 times negative 2, which gives us negative 2, and add it to your 2 right here, which gives us 0. Okay? Now we take negative 3/4 times a negative 2, which is 6/4, and add it to 7. Now 7 is 28/4. So 6 and 28 should give you 34/4. Okay? Once again, negative 3/4 times negative 2 is 6/4. And then 7 is 28/4, so 6 and 28 is 34/4. Okay? Now this will be pretty ugly, and since I don't have it memorized, let's find out what 39 times 4 is. 6, 3, 12, 156. Okay? So when you multiply negative 7/4 times negative 2, you have 14/4 plus 156/4. So 14 plus 156 should be 170/4. Okay? So now we're halfway there. What most people do at this point is just take this last equation and solve it and see what you come up with. So I could say, all right, I recognize that 34 over 4y is 170 over 4. So if I multiplied out a 4, I'd have 34y is 170. And dividing it, I have y is equal to 5. I can take this and plug it back into one of the equations and find out that x is equal to 2. However, I recommend doing a separate step, okay? Notice that you do not have a 1 on the diagonal here, okay? You don't have a 1 here, but you could get a 1 there just by multiplying by the inverse. So if you took 34 over 4 and multiplied it by 4 over 34, that number, 34 over 4 times 4 over 34 gives you a 1. And then 170 over 4 over 34 gives you a 5. And so what you notice at this point is that y is equal to 5. And that's on the right-hand side, so that is exactly the answer. Okay? Now, having said that, and I'll kind of shrink this to give me some more space I can show you. That's one finding, okay? I can then take that 5, plug it back into the first equation and solve and find x is equal to 2. Or I could take it one step further and realize that now since I have my 1 in my second column, I can use that number to figure out what I need to get a 0 in the first row, second column. So if I multiply 1 by 3/4 and added it to the first row, notice the 0 and the 1 in the first column don't change. So 0 times 3/4 is 0. 0 plus 1 is 1. So my first one doesn't change. But 1 times 3/4 is 3/4. 3/4 minus 3/4 is 0. Okay? And then all I have to do is look at what's happening in my farmost right column. 5 times 3/4 gives you 15/4. 15/4 minus 7/4 is 8/4. Another way to say 8/4 is 2. And so you notice if you have 1s on the diagonal and 0s off the diagonal, you have what's called an identity matrix, and the solution to your problem can be found in the rightmost column. Okay? So that's the matrix method. Now, this is relatively simple because I have 2 equations and 2 unknowns. Part of your discussion was trying to figure out when you should use which. And so what I'm going to do now is actually solve another system of linear equations using all 3 methods. And so you'll begin to see which ones are most beneficial and which ones are the easiest to use in which scenario. So let's start anew and we'll see where we take it from here. Okay, so here I have a system of linear equations. This time there's 3 equations, 3 unknowns. First equation, 3x minus 4y plus 2z equals 3. Second one, x plus 2y plus 3z equals 17. Third one, negative 6x plus 5y minus 4z equals negative 12. Okay? Let's try to use any of them first. So let's just try to use the elimination method. Say, okay, I notice on this first column, I have a 3 and a negative 6. So if I multiply my first one by 2, okay, I would end up with 6x minus 8y plus 4z equals 6, right? And then negative 6x plus 5y minus 4z equals negative 12. Now, we got lucky on this one because what happens, there's a 4 here and a negative 4 for the z's. So when we start to add the first and the third rows, we got so lucky because this cancels out and this cancels out. So we have a negative 3y equals a negative 6. So we know right off the bat y is equal to 2. Okay? Now the question is, what do we do from here? Because we still don't know what x and y are, or x and z. So I can consider the first equation again, which is 3x minus, now we know how much y is. So negative 4 times 2 is 8. So minus 8 plus 2z equals 3. And let me rewrite that because that one looks kind of messy. So I'll shrink that kind of. So again, we had 3x minus 8 plus 2z equals 3. Okay. And then so what I'm going to do is actually take the 8 on the other side. You end up with 3x plus 2z equals 11. Okay? And the next column, we can choose either one, but let's take that second equation, x plus 2y, but 2y is a 4, so x plus 4 plus 3z equals 17. So if I then take x plus 3z, it equals 13. Okay. So let's take these two equations, kind of give it some space, and see what we can do with these two. So if I have 3x plus 2z equals 11, and x plus 3z equals 13. Now I can use either of them. I can solve for any of them. And if I were trying to solve for x, I'd have to multiply the first equation by 3 and the next one by negative 2 to get rid of z's. But I just, once I see the 3 and the 1 and realize 3 is a multiple of 1, I can just say, well, I'd rather just multiply one time rather than 2. So I'll take that second equation and get rid of the x, multiply it by negative 3, and add it to the first equation. When I multiply it by negative 3, I get negative 3x minus 9z equals negative 39. Okay? And this first equation, if I rewrite it, you have 3x plus 2z equals 11. Now, let's simplify. Add them together. Those cancel out. I have negative 7z equals negative 28. So I have z is equal to 4. Now, since I have a y of 2 and a z of 4, I can use any of the three equations and find out how much my x was. So I like my second one. All right, I'll put that over there somewhere. I like my second equation because it says x equals something. So let's use that and plug it in and see what we get. So if we have x plus 2y plus 3z equals 17, then I know my 2 is y, so x plus 4 plus, I know my z is 4, 3 times 4 is 12 equals 17. X plus 16 is 17, so we see that x is equal to 1. So the solution using the substitution method is xyz is 1, 2, 4. You should have noticed a couple of limitations using this substitution method with multiple equations. Number one, you're not going to be able to solve directly for one particular variable, which means you have to do multiple steps to get to a single variable to then plug into another set of another set of equations to get your next answer. So it becomes more detailed when you have to do elimination by using multiple equations. But now let's take this same idea and let's try to solve using substitution. So that's next. Okay, here we go with substitution. Now I will say this. If you're not a big fan of algebra, then substitution you might not like very much once you get past two variables. Because you have to keep your signs right when you're subtracting. If you're subtracting a negative or multiplying by another negative, you can kind of get mixed up if you're not careful. So when you're using substitution with 3 or more variables, make sure you're careful to ensure that you're not making an algebraic error, which would then cause you to not find the correct answer. So just like with the two variable case, it doesn't matter which one you solve for first. So, but in this case, I am going to solve for x first because I see, using that second variable, x is sitting right there by itself. So if I subtract off 2y and a 3z, I know exactly how much x is. It depends on y and z, but x would be 17 minus 2y minus 3z. So I'm going to use this equation and find that x equals 17 minus 2y minus 3z. Okay? So now I can take this and plug it into either of my other two equations. It looks like the first equation will give me smaller numbers, so I think I'll plug it into the first equation and see what we get. So 3 times 17 minus 2y minus 3z minus 4y plus 2z equals 3. Okay? So if I have 51 minus 6y plus 9z minus 4y plus 2z equals 3. Okay? So let's simplify some. 9 and 2 is 11. Oh, sorry. See, already making mistakes. 3 times a... it's a negative 3. So 3 times a negative 3 will be a minus 9z, not a positive 9z. Okay, so 3 times 17 is 51. 3 times negative 2 is negative 6. 3 times negative 3 is negative 9. And then you rewrite those. Great. So I'm going to take the 51 on the other side because it's the only thing that doesn't have a variable with it, which gives me... Okay. So now 6 and 4 is a negative 10y. Negative 9 and 2 is a negative 7. Negative 7z. Okay. So what do we have? We still don't know how much anything is, but we have it in terms of another variable. Okay. So now I can then take the 6x and the 5y and the 4z and get a similar equation in terms of y's and z's. Then I can find out what I need to find. So let me identify this equation, okay, which got me to this point. Okay. If I then took this equation in that third equation, then I can get more of what I want. Okay. So I'll take this 17 minus 2y minus 3z, plug it into this negative 6x equation, get another y and z formula, and we can go from there. Okay. So I'll shrink that really small for you. And so we know that negative 6 times 17 minus 2y minus 3z plus 5y minus 4z equals negative 12. Okay? So, again, my math isn't as good as it used to be. 17 times 6, 2, 4. That looks like 102 to me. So if we have a negative 102 plus 12y plus 18z plus 5y minus 4z equals 12. Okay. If I can take the 102 on the other side, I'd have 114 looks like. So I end up with 114 here. And 12 and 5 is 17y. 18 and 4 is 14z equals 114. So now I have a 17y plus 14z equals 114. Okay? So we're getting uglier and uglier but we're also simplifying as we go. Okay? So we'll show you what happens next. 1 second. Now do notice one thing when we get to these other two equations, and that is, if you notice there's a negative 7z here and a 14z there, I could then take a first equation multiplied by 2 and get negative 14z, add it to this 14z and cancel them out. And then I could actually solve using elimination, which probably would be the best thing to do at this point. However, this is a substitution tutorial, so I'm going to continue, and so you can see how you would go by solving this using substitution. So remember, we have a negative 10y minus 7z equals negative 48, and a 17y plus 14z is equal to 114. On the next slide, we'll continue from where we left off. Okay, here we go. So we solved for x, and we plugged x into both of the other two equations. X fell out, we get this negative 10y minus 7z, negative 48, 17y plus 14z equals 114. And so at this point, it really doesn't matter which equation you use or which variable you plug into, because they both are pretty ugly. But let's just use the first equation and solve for z. Okay. First, I'm going to divide a negative 1 out, and I don't like negatives too much. So that would give you 10y plus 7z equals 48. So simplifying, z is 48 over 7 minus 10y over 7. Okay, now if you notice, we have a value for z. So we can take the z, plug it into the second equation, and find out how much y is, and then we can start finding some actual numbers. And that's what we're going to do here. So, get a little space here. 17y plus 14 times, this is 48 over 7 minus, this is 10y over 7. Equals 114. Okay? So we can see something pretty simple. The 14 and the 7s are going to cancel out. So 14 and 7, it gives you 2. So I'm adding a 96 here. And the 14 and the 7 gives you 2. So I'm subtracting a 20y there. And that's 17y equals 114. Okay? So if I subtracted off a 96 from 114, I would end up with 18. And if I then have 20 minus 17, I'd have negative 3y. So I should have a y value of negative 6. But for some reason, I don't think I do. You probably need to check the math again. So let's see what we got. All right, class. I'm glad I'm doing this real time with you guys, because if I went back to my previous slide, you'd see when we were deriving 114, that was a negative 102 and a 12. So it was negative 102 plus some stuff equals 12. And so I was guilty. Actually, it was positive 102. Yeah, who knows what it was. 102 and it was a minus 12, actually. So I was guilty of doing what I tell you guys to be careful of doing by not subtracting correctly. So that's why my numbers, while interestingly enough, were nice and full, they were incorrect, because I actually added 12 to 102 and got 114 when I should have subtracted 12 from 102 and got 90. So this number should have been 90, which then makes this stuff look a lot cleaner. And that means this number would have been 90. which means this number would have been 90, which means when I now have 96 minus 90, you end up with negative 6, so y is equal to 2, which is the answer I was expecting, considering I made the problem. Okay. Now when you have the y is equal to 2, you can then take it and plug it back in and find out what the z should have been. So we have z is 48/7 minus 10y over 7. So let's look at that. So if we took this equation, z is now 48/7 minus 10 times 2 is 20/7. So 28/7 gives you a 4. So now that I know that y is 2 and z is 1, I then can choose any of my previous equations and solve for x. So since we know that x plus 2y plus 3z equals 17, I can say, okay, 2 times 2 is 4. 3 times 4 is 12. Plus x is 17. X is 1. Again, we got 1, 2, 4 as our answer. I'm actually glad we had a little hiccup in there because you can see what happens when you have to do a long number of equations with substitution. So that's one of the limitations of substitution. If you don't do your algebra right, you can get into a mess. Okay? Now, my next thing I want to show you is the matrix method. And the matrix method is our final example, but this time it'll be on this three equation system. Okay? So next slide, meet me there, and we'll talk about the matrix method. Okay, so just to jog your memory, here were the equations we had. And remember with the matrix method, we're trying to get ones on a diagonal and zeros everywhere else, or at least below or above the diagonal and zeros everywhere else, and so we can solve for what's remaining. But when I look at this expression, again, that second equation gives me hope because this actually means 1x plus 2y plus 3z. So what I'm going to do is make my matrix, but I'm going to make this my first equation. So I would have 1, 2, 3, 17 is my first equation, 3, negative 4, 2, 3 as my second equation, negative 6, 5, negative 4, 12 is my third equation. Okay? So I already have a 1. So what I want to do is get rid of the 3 and the negative 6. So for my first equation, if I multiply this by negative 3 and add it here, and multiply the other one by 6 and add it here, I'll get rid of that 3 and the 6. And you'll see it in 1 second. Okay? So if you think about it, I'll rewrite the 1, 2, 3, 17. And we'll just do the algebra. 1 times negative 3. 1 times negative 3 is negative 3. Negative 3 plus 3 is 0. Okay? Now 2 times negative 3 is negative 6. Negative 6 minus 4 is negative 10. Okay? 3 times negative 3 is negative 9. Plus 2 is negative 7. And 17 times negative 3 is negative 51. Minus 3 is negative 48. Okay? And for the second one, we have, the third one, 1 times 6 is 6, minus 6 is 0. 2 times 6 is 12, plus 5 is 17. 3 times 6 is 18, minus 5 is 14. And 17 times 6 I don't have memorized, but it is 102. And 102 plus 12 is 114. And you know what? I made the same mistake I did last time. This is not a positive 12, this is a negative 12. So 102 minus 12 is 90. Okay? Now since we have the zeros below this, we need to change this 10 and make it a 1. So if we just multiply this by negative 1/10, then we would have a 1 where we needed it. So if we rewrote everything else, 1, 2, 3, 17, and just multiply it, 0 times negative 1/10 is 0. Negative 10 times negative 1/10 is 1, which is what we want. Negative 7 times negative 1/10 is 7/10. And negative 48 times negative 1/10 is 48 over 10. Okay? And the second one is, again, the same. 0, 17, 14, 90. All right, so now once we have the first one, we have to deal with the second one. What do I need to do to get zeros off diagonal here? Okay. Using that 1, if I multiply this by negative 2 and add it here, and multiply it by negative 17 and add it here, I'll get my zeros where I want them. So let's do it. Okay. Now, our second column is our frame of reference, so we'll just rewrite that. 0, 1, 7/10, 48 over 10. Okay. And we'll start multiplying. 0 times negative 2 is 0, plus 1 is 1. That doesn't change. 1 times negative 2 is negative 2, plus 2 is 0. That's what we wanted. 7 times negative 2 is negative 14. Negative 14 plus 30 over 10 is 16 over 10. Okay. 48 times negative 2 is negative 96. But then I have a 170. So 170 minus 96 should give you about 74 over 10, assuming we haven't made another math error. Okay, I believe that looks right. So 96, 170. Yeah, that's probably right. And then we go to the next column. 0 times negative 17 is 0. 0 plus 0 is 0. 1 times negative 17 is negative 17. Plus 17 is 0. Again, we like that. Now 7 times negative 17 gives you a negative 119. Okay? And 14 times 7 is 98. So a 98 minus 119 gives you a negative 21. So I have a negative 21 over 10 here. Okay? So again, we just did the numerators, and I think we still made another math error. Let's do that one again. Okay? So 7 times negative 17 is indeed negative 119 over 10. But then we have plus 140 over 10, which is 21. Okay. So again, we have 21 over 10. Okay. And finally, this is getting really ugly now. So 48 times negative 17 is negative 816. And 90 times negative 17 is 1530. So if I have a negative 816 minus 1530, actually that's a negative 1530. That's a 2346 over 10. Okay. So we have negative 48 times negative 17 is negative 816. And then 90 times 170 is 1530. So you have 1530 minus 816, which is 714 over 10. Clearly this stuff is getting pretty ugly, okay? So luckily, we only have one more set of steps to do, and then we'll get to our answer. Let's shrink this some. Okay. And let's look at what the last value is. Now, if I look at this third column, I want 1 in the third row, third column. So if I multiply that column by 10 over 21, I would get my 1 that I'm looking for. So we're just going to multiply this one by 10 over 21 and get something. Okay? So the first two rows, we're going to rewrite 1, 0, 16 over 10, 74 over 10, 0, 1, 7 over 10, 48 over 10. And now we have 0, 0, 21, 10 times 10, 21 gives you a 1. And 7, 14 times 10 over 21 gives you 34, which we know is not correct. So let's find out what we did wrong again. All right, so I made another math error, and you guys didn't catch me. And it's actually the last step that we made the math error. So when we're looking at 90, and we have the 48 over 10 here, and we multiply it by the negative 17 here, and we add it to the 90 here, that should be 900 minus 48 times 17 over 10. And if you do that, you end up with 84 over 10, not 714 over 10. Okay? So then, when you multiply that by 10 over 21, 84 divided by 21 gives you, in fact, your 4 that you are looking for, not 34. Okay? But we knew that x was 4, or z was 4 all along. So when you saw the 714, you probably known something happened that shouldn't have happened. Okay? So now our last two steps are to find out what x and y are. And of course, you can just back substitute here and figure out what it is. But since we're doing the matrix method, I'm going to go all the way and show you how you would get it. Okay? So what do you have to multiply by 1 to get rid of the 7/10? Negative 7/10. And what do you have to multiply the 16/10 to get rid of that? Negative 16/10. Here and here. Let's do it and see what we end up with. Okay? So 0014, that's our reference. We're going to leave it there. 0 times negative 7/10 is 0, plus 0 is 0. 0 times negative 7/10 is 0, plus 1 is 1. 1 times negative 7/10 is negative 7/10, plus 7/10 is 0. And 4 times negative 7/10 is a negative 28/10, plus 48 gives you 20/10, which is a 2. Now for the last one, 0 times negative 16/10 is 0, plus 1 is 1. 0 times negative 16/10 is 0, plus 0 is 0. 1 times negative 16/10 is negative 16/10, plus 16/10 is 0. And 4 times negative 16 is negative 64, plus 74 is 10. 10 over 10 is 1. So after a couple of painful errors, you can see your answer again is in this rightmost column. X, Y, Z is the same as 1, 2, 4. So this is what I meant when I said that you can use any solution you want, any tool you want to get the solution. They'll all come up with the same solution. However, some are more painful than others. And as you saw with the substitution, that could get painful. In addition, with the matrix method, it could get painful. And that's pretty much when you're dealing with multiplying fractions or substituting fractions in there and making sure that your numbers are looking the same. If you don't have a good handle on that, no matter which method you take, it could get hairy. But, I just want to take a little longer than normal just to show you that you actually can solve any system of linear equations with either the substitution method, matrix method, or elimination. And actually, there's multiple matrix methods, but that's beyond the scope of this course. So hopefully, you guys were able to grasp the idea behind this. Again, I'm kind of happy there were several arithmetic errors that were made in here because that got to the crux of the discussion question, which is what are some of the pros and cons of both? And the bottom line, if you're looking at two variables, an x and a y, it doesn't really matter which one you use. They're relatively simple. And I would argue that the matrix method would be overly complicated for a 2 level. But once you get into 3, 4, 5, 6 variables like length, width, height, or pressure, temperature, volume, and you've got to solve all these at the same time, the matrix method will probably be your best bet, in my opinion. Well, that's it for me. Hopefully you guys have found this useful, and I will be talking to you guys soon. Take care. Bye.